Okay, so in this video I want to talk about dimensional analysis. And dimensional analysis is maybe a method we use to change from like one unit of measure to another. Right, so if I measured, let's say my kitchen floor in like square feet, but then all of the tiling is in somehow like centimeters or something like that, then I need to convert one to the other, right? So we use, let's say, a problem might be like I ran 3 miles today. Like, how many feet is that? Or maybe yards is that? Right? So where I have something measured in one set of units, which in this case would be miles, and I want to figure out how far that is or how long that is in a different set of units. Okay. We use in these problems something called a conversion factor. Conversion factors are conversions from one sort of measurement, one unit of measurement to another. Like in this case, for example, in a lot, like some common examples would be things like 12 inches is the same thing as 1 foot. Or that 3 feet is the same thing as 1 yard. These are two very common conversion factors, right? Okay. So the fact that these are equal means there's a relationship between them, right? That's what we learned about equality. They're equal. And so what it also means is that I can multiply by a fraction. So 2 conversion factors are possible out of here and out of every single kind of equality of this sort. One, it's that because 12 inches and 1 foot are the same thing, this is the same thing as multiplying by a fraction that's 1, right? So I'm going to use this and fractional reasoning to convert. So the same thing is over here too. The 12 inches, if that's on the bottom and 1 foot on the top, that's the same thing as multiplying by 1 over 1. Okay, same thing here. 3 feet over 1 yard and 1 yard over 3 feet are the same sort of conversion factors. And again, I can multiply on by this fraction without changing the quantity. So for example, let's say that I have, let's do this simple problem. So I want to say, like, how many inches are in 40 yards, right? Okay, so what I know is that I have something and it measures 40 yards, and I want to know that in inches. And this is the blank that I'm trying to fill in, right? Okay, so then I'll have this start over here. That's 40 yards, what I know already. And at the end, I don't want this units to be yards, I want it to be inches. And then I want to have something here in this blank. Now, what dimensional analysis tells us is it tells us how to convert or which of these conversion factors to choose, right? So let's say I'm going to go, I don't know how many inches are in a yard, but let's say I'm going to use this yards to feet first. So I use dimensional analysis by multiplying by one of these fractions. So I'm going to multiply by a fraction, and it's going to be, I'm going to go from yards to feet, right? And so I can either do this fraction here, fraction 1, or this fraction here, fraction 2. And what dimensional analysis lets us do is pick the right one. So here, I want yards to go away, right? I want to get rid of that, which in fractional reasoning means if I have yards on the bottom, these cancel just like fractions cancel, right? And then if I put feet up here on top, then feet will be left because it doesn't cancel with anything. So then I put these numbers in. That's 3 feet over 1 yard. Okay. And then I still want to go to inches, so I'm going to use this conversion factor, feet to inches. So I'm going to multiply one more time. Now my measurement is in feet. It first started in yards. Now I've moved to feet. Now I'm going to move finally to inches. So again, I want to cancel this feet. So I put this, I'm going to use this conversion factor, the one with feet on the bottom and inches on the top. And then I put in the numbers that make that equal. So 12 inches is 1 foot. Okay. And then I do this problem. So this problem on my calculator looks like 40 times 3 times 12. That's across the numerator. In the denominator, I'm going to divide by 1. That's this one, right? And here I'm going to divide by 1 again. That's this one. And usually people will leave this out because dividing by 1 doesn't do anything, but I put it in to make sure you know sometimes there are numbers in the bottom and then you have to divide by them. Okay, 40 times 3 is 12 times 12. 40 times 3 is 120, sorry. And then times 12 again should be, I think, 1,440. Let's check that on my calculator. Mostly because I don't want to make this video. Oh, that's good. So it's 1,440 inches. Is that okay? And so the main thing dimensional analysis again does is it says, okay, I want to cancel this, so I put the same thing in this denominator. And what I put in this denominator determines then what these, like kind of where I'm going, what I can put up here, and then what these numbers are here. And then here I want to cancel this guy, feet, so I put him in the denominator. That means it determines like how many inches I can go in the top of this. Okay? Okay. Let me see. I have another couple conversion factors, and let's do that. Let's do this. So one of the conversion factors is I know that 1 mile is 1,760 yards. So let's do this. What are the problem? How many yards is that? So let's do this 3 miles to yards, right? So let's say I ran 3 miles. How many yards is that? Oops, that's a statement. How many yards? So again, at the start, I have 3 miles. At the end, I have yards, and I'm trying to figure out how many it is. And then I have this conversion factor, right? And this goes to either 1 mile over 1,760 yards or 1760 yards over 1 mile. So again, I'm trying to cancel and get rid of miles, so that goes in the bottom, which means yards, which I'm trying to go to, goes up top. And then I just put the right numbers in, 1760 over 1 mile. And that's it. This is a one-step problem. So I'll get 3 times 1760 is 5,280. Okay? Okay. Then the other thing I want to talk about is this, maybe let's do an example with the metric system. So the metric system relies on it's very standardized and very nice. So it relies on like this prefixes. So like the first one is kilo. There's a hecto, deca. Some of these are used more. And then this is called the base measure. In the metric system, the base measure can be things like meters, grams, liters, right? So you can have kiloliters or kilograms, all of those things. But this is called the base right there. Then we have the decimeter and centimeter or centiliter or centigrams, and then millimeter, or right. So it has all of these prefixes, and they kind of tell you what it is compared to the base. So this kilo, like let's do kilometers. There's 1 kilometer is 1,000 meters. That's what kilo means. 1 hectometer is 100 meters. 1 decameter I think it's capital DM. It's not very widely used, except it is like there's, I think it's used in one like context. I can't remember what it is right now. Then decimeters go the other way. So there are, in 1 meter, there are 10 decimeters. And 1 meter has 100 centimeters. And then 1 meter is 1,000 milliliters or millimeters. Okay. So these are all conversion factors, and again, we can use them to convert. So let's say that I have, let's say 362 kilometers, and I want to transfer and convert that to, let's say decimeters. So what people will do is they will go from kilometers to the base, and then from the base here, usually. So it depends, like if you're crossing this base, if you're going across here, sometimes people go in between here, but so I'll set up again, the start is 362 kilometers. The end is decimeters. And I want to know how many that is. And again, I'm going to use this conversion factor. I'm going to set this up. Kilometers should be in the bottom. And then I'll put meters here, because I know there's 1,000 meters in 1 kilometer. And then I also know, now I'm going to cancel. So that cancels these, right? And now I'm going to cancel meters with meters. Set that up so they cancel. And then I'm going to go to decimeters. So there's decimeters. And there should be 10 decimeters for every meter, right? So I'm going to multiply by 1,000 and then again by 10. So really that's 3, 6, 2, and then 1, 2, 3, for 3,620 decimeters. Is this okay? If you're on the side multiplying these two together to figure out what the conversion is from kilometers to decimeters directly, that means you're doing the dimensional analysis on the side, and you should really just do it as part of the main problem. The idea is not to like make this shorter. The idea is to show work that substantiates how you're transitioning from kilometers to decimeters. So the idea behind dimensional analysis is to show all your work here. So if you're doing some sort of side multiplication where you're like, well, 1,000 meters and there's 10 decimeters, and so when I multiply them together, I get like something 10,000, and then you're using 10,000 in this multiplication factor, you're actually just doing part of the process over here and part of it over here, and it just makes it unclear what you're doing is what it does. So just show all work. It's kind of should be in one kind of horizontal line that you're doing that. Okay, let me know if you have any questions.